Hello everyone, my name is Magno. I'm the founder and CEO of Scientia, and I'm here to talk to you about reinforcement learning applied to corporate finance, specifically to startup finance. We'll be sharing the whole code. It's coded with Tensorflow, so it's really cool. I'll share the pre-trained model as well, so you can train your own version of the model, change the parameters, and see what happens. And you don't even need to start from scratch if you don't want to. So let's start talking a little bit about what is reinforcement learning. And before we do that, let's talk about machine learning in general. Machine learning is concerned with the relationship between variables. So, for instance, in image recognition, we are trying to figure out what is the relationship between the pixels in an image and what's in that image. In natural language processing, we're trying to figure out what is the relationship between the words in a phrase and what is the meaning of the phrase. And in many social media algorithms, they are trying to figure out what is the relationship between past behavior and future behavior. Well, with reinforcement learning, what we're trying to do is figure out what is the relationship between the state and the different actions that you can take and what would be the consequences. And we're trying to do that in a specific way, meaning we are trying to figure out what is the optimal actions given different states that would yield the highest reward or would do a task in the best way. As we can see, reinforcement learning has some interesting examples, interesting applications. If you look it up, most examples you probably find out is game playing AI, which I think it's very cool, very interesting, but it's also a bit silly, I guess. It's hard to see real life and interesting applications to reinforcement learning other than game playing AIs. You have few and far between examples. I guess the most notable ones are probably the driverless cars. They're still a few years into being finished. You will have AlphaGo, the AI that beat the Go champion, which is like a Chinese version of chess. And you also have a lot of robots that can learn to go through obstacle courses, and which is very cool. But you don't see that many examples of what you can do with this technology. And so we're trying to show you what we can do with it in terms of corporate finance. The idea here is that every year a decision maker has a set amount of available resources in his startup, and he needs to decide how much discretionary spending he's gonna have. And discretionary spending is something that makes them happy because they can give bonuses, they can do parties, they can buy superfluous stuff, and so it's something they probably want to do, but they also want to save money because they want to make it to the long run. They don't want the company to actually go broke, um, because if the company lasts long enough, he can sell it for quite a bit of cash. We have two types of startups: a booming startup and the flop. Both of them start with similar growth patterns, but the startup is gonna keep growing exponentially, and the flop is gonna pretty much flat out. So it's not gonna grow as fast as the booming company. Our bot, the bot that we're building, doesn't know anything about this. Doesn't know about booming, about flops, or about how startups work. He's gonna just have to play and learn by doing different things and seeing what happens, right? The idea is the company starts off having losses, and eventually, especially if it's a booming company, it's gonna have large profits. So he wants to make it till the end, so the company eventually gets sold and he can make millions and millions, especially if it's a booming company. So we have four main concepts to our problem. The objective, meaning what is what is it that you're trying to do. We are using the consumer capital asset pricing model, which is a very um, I guess standard model in economic theory. We have the environment, which talks about what's going on, what's happening. So we have the different in the environment. We have the different types of startups, the booming or the flops, how much profit the company made a given year, the valuation if the company does get sold in the end, the rewards, which is the consequence each year of each decision that the bot makes, the available resources, which is how much money the company has on the bank, and he needs to decide how much they're gonna save and how much they're gonna use for discretionary expenditures, and interest rates. A third concept that is very important is learning. We use Q-learning with Tensorflow using neural networks. Again, as I said, we're sharing the code so you can play around with your own version. Um, and finally, we have the results, which is what happened to the training, what happened to the outcomes, and the decisions. So, in terms of the objective, every year the decision maker has an amount of money in their available resources, and they need to decide if they are going to use it for discretionary expenditures, which is pretty much potting, and how much they're going to keep on the bank, so they're going to save. If they last long enough, which they don't know how long they need to last, eventually the company, if the company still exists, the company gets sold. Even if it's a flop, the difference is the booming company is gonna be sold for a lot more than a flop. Then we have the environment, which is very related to if the company is a booming company or if it's okay. It's just a flop. If it's a booming company, it's gonna have a lot of resources. Profits are gonna keep growing, and things are gonna go very well. And if it's an okay company, then it's gonna see a lot less money. In terms of learning, we start with a baby robot that doesn't know anything and acts completely random. He tries a bunch of different things and sees what happens. Eventually, he starts learning and figuring out what happens and makes the starts to figure out what are the best decisions to make. And in the end, we're gonna have a stable AI that has pretty much decided on what it's going to do. In terms of results, here we have the utility, which it would be like a happiness measure or how well the robot performed or AI performed. We can see that it started kind of slow. This is the overall results, and eventually it quickly learned how to perform better, and eventually took a long time, fluctuated a little bit, and settle a little bit and a little bit better, or there wasn't too much of a difference. In here we unpack what were the results for the booming company and the flop. Remember that the robot doesn't know if the company is gonna boom or if it's gonna flop. The only two things he knows is how much money he has on the bank and what year it is, and from that he needs to decide how much money, how much available resources they're gonna set for discretionary expenditures. So we can see that the happiness or the utility or the results for booming companies are way higher, and for flops it's a lot lower. What are the valuations? If the company makes it till the end, the company gets sold. If the company goes broke, we say that the valuation is zero. So as we can see for the full run, it quickly starts learning, and it reaches much higher valuations on average, meaning there's a lot more companies that actually make it till the end. And then it's has a very small slope, but there's some learning going on over here. Especially for booming companies, we can see that the averages are actually higher, meaning there's a higher chance that they actually make it till the end, and they're also saving more money. The valuation is also attached to how much money you had available as available resources at the final year. And for the flop, we can see that the valuations are pretty close to zero. It's not zero, but it's pretty close. Meaning there are a few companies that actually get sold, and of those, the value is quite low as well. The idea is the robot needs to think about if he saves money, the company may not make it, and he lost the opportunity to actually enjoy it. He may have worked very hard and still got nothing for it. And on the other hand, if he spends too much money, the company may be a booming company, may be a great, may have a great result, and he lost a chance because he lost the chance of making millions by the end because he just spent everything on silly things, on superfluous things. In here, we are considering that there's a 15% chance that the company is going to be a boom and an 85% chance that the company is going to be a flop. And again, we on the code you can change all the parameters and see what happens. Duration is how long the company is going to last. On average, we see that it starts by lasting on average 6 years, and as it learns, it jumps. The average time it lasts for, and pretty much settles close to 8 years. For booming companies, the average duration is a lot higher. We consider that if the company lasts for 12 years, in the 13th year it gets bought. So we see that if the robot realizes that he has a company that is performing very well, he'll try to do his best to actually make it till the end. And if you have a flop, we see that the number of years that it lasts is a lot smaller. It's between 7 and 8 years. The idea is, well, if you don't think that you'll actually make too much money, even if you do get to sell it, you probably would like to spend more than just keep it on the bank. Available resources is how much money they had on the bank at their last year. If the company goes broke, we consider that the available resources is zero, and if the company gets sold, in the last year, it's probably gonna have a positive bank account, right? So, on average, we see that it quickly learns to save a little bit more money, and there's a kind of on an upward slope over here, especially for booming companies. They're saving ever more, more and more and more and more. And for flops, we see that they save very little. It's very close to zero. So even if you do want to make it till the end, you probably don't want to have too much money on the bank. You want to just spend it as much as you can. Finally, we have here the proportions of companies that actually get sold or actually get till the end. They last for 12 years. So we see that in the beginning, only 15% of companies make it till the end, and booming companies actually were 15% of the companies. So it quickly jumps, and as we can see, um, there's quite a bit of amount of companies that actually make it to the end. Remember that only 15% of the companies actually are booming companies, right? And in terms of the booming companies, we can see that they start out at 25% and they keep rising and reaching about 50%. So even if the company does boom, if the robot is incentivized to spend money on themselves, and it may get some bad results. So there's a lot of randomness to the problem to make it interesting. So it's not a safe bet that they'll actually make it till the end. And for flops, we can see that the rate of companies that actually get sold is very much smaller, probably between 25 and 30%. And it does rise a little bit, but it's not that high. You don't have as a strong incentive to actually make it to the end, because even if you do sell it, you won't be selling by for too much. The average proportion is the actual decision that the robot took. It's how much money he's allocating to discretionary expenditure. We can see that in the beginning it starts really high. We limit the amount of money he can allocate to discretionary expenditures between 0 and 30%. So it starts pretty close to the maximum. Because he realizes that discretionary expenditure is good, but as he actually gets to the end, sometimes he realizes that if he's more patient, he can eventually sell the company for millions of dollars, especially if it's a booming company. So he starts to act a lot more conservatively, and he keeps spending less and less and less as he learns. Especially if the company is a booming company, they start saving more and spending less. So if you actually see that things are going well, you'll probably be more conservative instead of actually spending more. You probably be saving more. And if you have a flop, since you don't know which kind of company it is, you still try to save quite a bit. But if you see that things won't be going that well, you probably won't be saving as much as you would. We can see how interesting this is, because it's actually the quality of the company that determines how much it's going to spend, or how well it's going to control its finances, and not the other way around. And the other interesting thing is, if you actually are doing well, instead of spending more, you'll be spending less, at least in this model. And if things are not going that well, you'll probably be wanting to take advantage of the money you have in the bank as much as you can. So you'll probably be saving less than you would if things were going well. So if you're probably not gonna make millions and millions of dollars, you don't want to. You want to actually spend the money on yourself. And that's it. I hope you guys enjoyed it. we'll give the links for the model, the script, and the code that you can see a bunch of different things on the comments. Do visit our website. Stay tuned. We're gonna try to create more and more interesting content. We are also going to make um, an interactive version of this little robot that we made, so people that don't know how to code can still try it out. But it may take a little bit, a little while. But you can just look at the code for now. Okay, thank you, everyone. Goodbye.